Hi and welcome to class 10. This week I'm going to follow up on something that was mentioned in the forums, and that's dealing with external data in Cinema 4D. For this I'm going to start with a rather simple example where we're going to read in some XML files and use the data in those files to move an object around. And then afterwards we're going to look at a bit more complex example, and much more interesting to be honest, where we're going to use the OSC, the Open Sound Protocol, to communicate with an external application and use that to update data within Cinema Live. But let's get started with the XML example first of all. So for that we will start with a very simple scene, which is just a cube and a Python script. There we go. Let's get rid of the comments here. Right, so to use XML files, there is a module in Python that already comes with it called XML, and we're going to import that. And within the XML module there are a number of ways to work with XML. The easiest way is the so-called element tree, and that's part of the E-tree module. And in there's the element tree. And we're going to import that as ET because that's shorter, and that's what's commonly being used. So with that imported, we can use it, and first of all we are going to do the standard stuff. So we will need the current frame, so I'm doing the usual thing here. We're getting the time. We're getting the frame based on the time, and we're converting it to a frame number based on the frames per second. Alright, so we of course need to get an XML file in here, so for that we are adding a user data field. Again, that's something we did before. And it's going to be a file name field. I think we haven't used that before. So that's basically just a string field. So let's call it file name. There we go. And we're dragging it into our source. And of course it's the user data of the object itself. So it's op. And we're passing it into a variable called file name. So there we go. So that's where we get the XML file from. Now, for the XML file, I'm using a very simple file I've written in here. So it's just a basic XML. I haven't really done much with it. And in there, I'm defining an entry for each frame number, and I'm just putting in some coordinates. So these are all put in as attributes. That's much easier to handle than using separate tags for everything. So basically what I plan to do is I'm planning to read in that entire document and then loop through the frames, and for each frame compare it to the current frame number, and then if I hit the right one, I'll take the x, y and z coordinates and pass them on to an object. So very straightforward. That's something you could think of as I don't know, some data export from some other animation, some other software where you exported all the animation keys, for example, and those keys would then be exported as X, Y, and Z coordinates, and you could use them in Cinema again. But this can be anything really. So back in Cinema, we have our file now. So to get that file, we have to create an element tree, and we're just calling it tree. And it's from the element tree module, and it's called element tree. So that's creating the basic element tree object, and then that object itself has a parser, and that parser expects the file name of our XML file, and that does most of the work for us really. So that converts the file or the XML within the file into an object. Now that we have the object, we can get to the data through iterators. So the tree has another function called getIterator. Did I type that correctly? Yes. And the iterator expects the name of the tag, of the XML tag, that it should iterate over. So, I mean, if you're not familiar with iterators are basically just an object that's jumping from one entry to the next. So it's just basically going through, well, you're telling it, give me the next one, and it gives us the next one in a sequence. So it expects one of these here. So if I were to get an iterator for animation, it would give me this animation object here, from here to here, and that would be it, because there's no next one. But what we want is a frame. So when we get an iterator of frame, it will give me this one as the first object, and when I tell it to give me the next one, it will go to the next, and the next, and the next, and so on. So we are looking for frame, and that's what we write here. So that returns the iterator. But for our purposes, it would be much easier to deal with a list. So what you can do is you can use the list command and put the iterator into the list, and that will return a regular old list, Python list. And that list, in turn, we can put into a variable. So there we have it, that's our list. And now we can use a regular old for loop and for f in frames. And that will return us a single entry of that XML list for every one of our loop steps. So once in there, we can check the data by using f, that's our frame, and then dot attrib, which means it's going through the attributes of that XML entry. And the attributes are what you see here. So these are the attributes, number, x, y, and z. So I can just go and tell it to look at the number, and that will return the value of that attribute as a string though. So when we get this back, it's returning the number, which is like 0, 1, and 2, but it will return a string of 0, 1, and 2. So when we compare it with something else, like the current frame, we have to make sure that we change that into a string as well, otherwise the comparison fails. So if I were to tell it to just compare it with the current frame, and the current frame is, I don't know, let's say 3, then here we would see an integer 3, and here we would see a string of 3, and this comparison would not be equal, and this would fail. So what we need to do is we have to turn this into a string, and that automatically recognizes the number and turns it into a string of 3, and then when we compare them, this would be successful. So, and now we know that we're in the right frame, and we can just get the remaining attributes and turn those into a vector, for example. So we just take the c4d vector, and let's make this a bit bigger because we need more space. And we take the f attrib x, and that would return the x value, and we need that 3 times, of course, because we have x, y, and z. And to remember what I just told you a second ago, that this returns a string, that same problem we have here as well. These are strings, and the vector function won't like that. So we turn those not into integers and not into strings, but into floating point. Oops. Let's do this for the others as well. Okay, so now we get a vector. And that vector we can use to get the object that the script is on. So it's op.getObject. Remember, we have done that before. So that's returning us this cube here. And then we call the set abs pos to set the absolute position, and we're passing in that vector. And if all went well, let's see, no errors. Well, if all went well, then this should already work. Well, actually no, because first of all, let's clear this. It can't work because I haven't selected a file yet. And there we have it. So that's the file I showed you in the editor. Let's open that. Let's see what happens now. Okay, no error message. That's good. Let's move this here. And there we go. You can see the movement. Can you see it? Okay, let's go back further in here. Actually, let's make the cube smaller so it's more visible, because I didn't really move it that much. But if I'm pressing play now, there we go. So you notice that I only put in values from 0 to 25 in here. So that means we only get animation between the frames 0 and 25. Now there's a small trick to make this loop, and that's using the modulo calculation. And that's very useful to know for all kinds of looping data you have, for, like if you're using image sequences, for example. So it's very easy. All we need is the amount of frames that we have, and we have those already in our list here. So we just count the number of frames in that frames list here, which is easily done with the len function. So let's put the len. And you see already here it changes the color, so that's a known function, that's a system function. So it's len frames, and that's going to return the number of frames we have in here, which is 26, so from 0 to 25. And we're using this percent sign in between. That's the sign for modulo. What modulo does is it divides one number by the other, and it returns the remainder of that division. So if I divide, let's say if I divide 10 by 2, it would return 4, because 2, well, it would return 4 with a remainder of 2. So it's a division that it's an integer division, not a floating point division. So, and what that does here now basically is that when the frame goes over 26 and we divide it by 26, it goes back to 0 and then counts back up. So when so basically whatever number is in here, we will never get more than anything between 0 and 26, meaning that this will now, hopefully, if all goes right, and it should, this will now loop, and it does. And let's see, let's make this 104 frames, and that should now be looping correctly. There we go. So clearly this is a very simple example, but you can hopefully already see that this could potentially be very powerful. You could combine this with what we did in the last couple of weeks, where we set keyframes. So what you could do is you could, because normally you may not have lists of for every single frame, you may only have keyframes. So what you could do is you could loop through this, and whenever you hit one, you could use that to set the appropriate keys in the timeline. And we did that in the last few classes. So that would be one thing to do with this. And of course, you could also use this to cache out your animation. So you could read in your current animation, write it into an XML file. We did that before. And when you're done, you could use that very same file to read it back in and play back the animation. That's just one example, but there's plenty more you could do with it. You could export and import like other attributes of your items. So yeah, plenty of stuff to do with this. So I hope this was helpful. In our second example, we're going to go one step further and create a live connection through the network to another application, and that's being done through the OSC protocol. So let's close this and get rid of this. for this example, we're going to leave Cinema for a moment, and we're going to look at a website, and that's this one here. And that's the Open Sound Control Protocol. It's a relatively simple protocol to for applications to communicate with each other over the network, and it's very commonly used, well, as the name says, in audio hardware, but also in with other multimedia installations, and with any application where the different parts of the application need to communicate with each other, and where you don't want to implement complex protocols, really. So to use this, you can use a Python module, and that's this one here. And I'm including the module with the files for this class so that you don't have to download it here. But you can, of course, have a look at this here to find the documentation, because I'm not including that. And that's implementing the OSC protocol for Python. And you should also have a look at this thing here that's called processing, and that's Java based, and I chose this because it's very easy to use, and it already comes with OSC implemented to begin with, and it runs on Windows and on the Mac. So both of you guys, or all of you guys, should be able to follow with this example. So I'm including a so-called sketch, which is a processing application with this class. And what it looks like is this. So once you downloaded this and started it, you can just open the file that I included, and this is what it will show you. And it's super straightforward to use. You don't really have to change anything here. All you have to do is press run here. And when you run it, it's going to start, well, this small window here, and nothing much is going to happen. But you can already see here that there's something running here and listening on port 12,000. So the more important port, though, is this one here. And what OSC does is basically you have a client-server architecture, and the clients are sending stuff to the server, which collects the data. And in our case, the server will be Cinema 4D, and the client will be this small application here. And what I plan to do is I will create data in here, and I send it into Cinema, and Cinema will catch up the data and will then do something with it. So let's stop this for now, and let's look at how I implemented that in Cinema. So let's see, I have this, where's my editor gone? Let's put that at the correct position, there we go. So I implemented this as a plugin, and the reason for this is in the course of this plugin, we are going to create a server to listen to the data coming in over the network. Now, if we were to use a regular script, that would be evaluated on every frame. And on every frame, it would try to create a server, and on every frame, we would run into the problem that the port that the server is using is already in use. And we would get error message and all kinds of trouble. Whereas with the plugin, this runs as a separate thread, and the server will run on its own, and we just have a start and stop button, and much more convenient. So let's go through it as before, top to bottom. So first of all, we have the c4d modules. Then we have the OS module, which we only used to read in the icon as before. And then I'm importing the OSC module. Now, by default, this does not come with Cinema. So if you were to run this, you would get an error message because the OSC module is not there. What you need to do is you need to add the OSC file that I told you will be part of this class into the side packages folder of your Python package. So we're going into the Cinema program folder, and in there we're going to resource and modules and Python, and that's where the file is. And in this resource folder we have 3 different frameworks. I think I showed you this in the very big first class. So we have these 3 frameworks, and it's important that you go into the one that corresponds to the operating system you're on. So currently I'm on Windows 7 64. If you were on a Mac, you would go into the OS X framework clearly. And if you are, which is rather unlikely, if you are on a 32-bit Windows, you would go into here. So let's go to this one. And within the framework, all of these look exactly the same. So this one here looks exactly the same as the OS X one. Well, actually, well, where it counts at least, within here, in the lib folder. There you have the side packages. And there one, and libs, nope, lib. There we go, side packages. Those look the same. So in that side package, so basically you go into framework, lib, and side packages. And side packages means you can, that's the folder where you can put in your own modules, and those will be found by Python. So I already put that file in here. That's the osc.py, and that's all you need to do. Once that's in there, Cinema will be able to find this module. So if I go into Cinema now, and you remember that in our console I can actually type in Python Python commands in here. So if I type import osc, and it comes back with OK, and that's finding the module in here. So please check this first of all. So basically the first thing you should do is copy that osc.py file in the side packages folder, fire up Cinema, and run the import osc statement in here. And if that comes back with an error, then well, it hasn't found it inside packages, so you have to double check that. If it comes back with OK, which it should, then you're good to go. Right, so let's go back to the plugin. So we have imported OSC. Then I'm just setting a couple of numbers here as global variables, just so it's easier to read. And I'm using a development plugin ID. So if you already played around with plugins, make sure that you haven't used this for any of your tests. Otherwise, just change it to something else. Then I'm creating the dialog. So I am using a rather simple UI. So I'm just creating the dialog straight into in the code. And it's just a couple of text fields where I'm setting up the server's hostname and the port and the poll every millisecond. So how this works is the OSC server that we create in Cinema will check for new messages coming in every so and so many milliseconds. And well, I have to tell it how many milliseconds should be between every poll. And I've decided to go with 10 milliseconds for now. You can increase this or you can decrease this. If you increase this too much, then you will notice a significant amount of lag, because it will not drop the messages. They will just come in much slower and it will be lagging behind severely. If you make it too fast, then you may notice some slowdowns in Cinema because it's not keeping up. So 10 seems to be working fine for me. If you want to change it, you can just change it in here or later on in the UI. So, right, so these are just a couple text fields for configuration. Then I have a link box, and you remember that when you use the resource files, it's very easy to create link fields. It's not quite as easy, unfortunately, when you do it in the source code. So, because the link box is considered a custom GUI field, so you have to create it using the add custom GUI. Then you're passing it an ID number, which I have defined here, but you're not actually using that later on to access it. So what you're using to access it is the return value that you get from the custom GUI. That's this variable that I define here. So anyway, that's the ID. That's the custom GUI that we want to start, and the identifier for the link box is this. And I had to look that up in the header files. So just remember that. And that's being ignored. That's just a name for that field, but it's not actually using that. That's why I'm using the static text to put in front. And that's just the positioning. So our data will be in here, and that's what we are going to use to create a target object where we put our positional data that we get from the processing application, and we will use that to change the position of this object. And then I'm adding a button to start and stop the server. Now then I'm initializing those fields, because otherwise they will all start up with none as their value, and we don't want that. So I'm just putting in the local host number, and 32,000 is what I have defined in the processing script sketch. So here, that's, if you want to change this, you can change this here, but you also have to make sure to change it here or later in the GUI. And this is just a status a variable that I set that lets me check whether the server was started or not. So currently it starts as not started, as false. Then I'm going to skip ahead a bit. Well, this is the initial class that's being created, and that's doing nothing but just starting up the dialog. What we want to look at first is the command, and the command catches the run button. And when I click that, it checks this aforementioned status variable, and if this is true, meaning the server was started, then when we push a button, it will stop the server, and if this is false, it will start the server. So before we stop it, let's look what it's looking like when we started. So we started using the OSC module and its OSC server method. And the OSC server method is rather easy to use. It only expects a host name or IP and a port number. What's a bit special is it's expecting those two as a tuple. A tuple is something like a list. It's a read-only list basically, and it's being defined as, well, you have a bracket and value A, value B, and those together with these two brackets, they are a tuple of two values. So what that means is all you need to do is you have to pass in the host name and the port and make sure they are both together surrounded by parentheses. And then you pass that block into the OSC server. And that's all. So that's the only peculiarity here. And then you get back the OSC server object, which we put into our variable server. Next step is to add a message handler to this. So OSC messages basically work by having a message name followed by all the values that you want to send to, with it. So in our case, I have decided to send the mouse coordinates, mouse X and mouse Y, in a message called coordinates. So I'm creating a message that's being called coordinate, and it's being followed by two integer values, mouse X and mouse Y. Now I'm not going too far into this function here because I don't want to do Java with you. But you can see here it's rather easy and rather simple, and what you get is just a string with this at the beginning and then followed by these values. And on the receiving end, you have to make sure that when our server catches a message, we want to check those messages for that string. So there could be all kinds of other messages floating around. And if it's a message beginning with coordinates, then call this function. That's all there is to it. So this message handler just picks up on this message, and if it catches it, then it calls this function here. And this function I have defined up here. And what that does is this, first of all, this profile here, that's always the same. So you have to use this function. You can change the name, of course, in front of here, but this has to stay the same because this callback here expects these parameters. Then what I do for debugging is, let's do this now. I am printing out the arguments that are coming in. But as I say here in the comment, when you use this in production, you have to comment this out, because printing out anything really slows down Cinema a lot. And then when you get the arguments, you can use those to, well, in my case, I use those because I know arguments. The first one is the mouse X and the second one is mouse Y. So I'm just using them to create a vector with X and Y, and that will always stay 0. And then that vector I pass into the set absolute position, and I'm taking the link box. I'm getting the link from that link box, which will be our target object, and I'm setting that target object's position through this. And then I have to make sure to call event add, because otherwise Cinema will not redraw our box. So our target will get the new position, but it will not show up. So you have to call this every time. And that's basically the callback. Now, what's special about the callback is it requires you to not return true as with most other functions. So it expects either nothing as a return, or it expects an OSC message. So in our case, we just return nothing. So once we're done, we just finish this function. We don't return anything. That's important, otherwise you get an error message. So once this callback has been defined, then we start the timer. This timer is a Cinema 4D function, and when we set the timer, we pass it in our poll time. That means this timer is being started every so and so many milliseconds. And every so and so many milliseconds, this will be started, and it will call our server and its handle request function. Handle request checks for incoming messages. And when a message comes in, it automatically checks its message handlers, which we have registered here, and then checks for this message and then calls this. And once again, the timer also returns nothing. That's important. What else do we have here? Well, we set our server started to true, and we're just giving out some status messages so the user knows that we started it. And that's really all there is to it. So the biggest part really is just building up the GUI here, and the actual application is just this. So that's very straightforward, really. So just to reiterate, so you understand what's going on, when we press the button, we start the server here, we create the server object, then we add the message handler to that server object, and that message handler is being used when the timer is calling the handle request. Then it's checking the message handler, and if the message handler finds a fitting message beginning with coordinates, then it's calling this callback function, which is this one here. It executes it and then keeps on looping. And when we press the button again, it just stops the timer. So it sets the timer to 0, which effectively stops it. We change the value to false because it's not running anymore. And we close the server. And this is very important, because if you don't close it and you want to start it again, you will get an error message that the port is already in use. So you need to close the server for it to start again. Otherwise, you need to close Cinema 4D entirely and start it again. So that's important. Right, so that was a lot of theory. Let's have a look at the practical application. So our plugin is already in here, so I'll start this, and you see it's rather simple UI, and I have my data already in here that support the host, the IP every 10 milliseconds, and let's create a target, which will be just our cube here. Let's put this out of the way and make this more like this. Actually, let's go to a front view, because I have, well, I'm just setting Z to 0 anyway, so this should move around. Let's go back to our processing sketch. Press 1 as our window. Let's see. So you see here when I'm clicking, there's a button. And let me just start Cinema. Let's get this bit, and nothing. Of course, I have to start our server. And you're telling us it's listening. And there we go. Something is happening. And you can see here, it's moving around with my mouse. And you can also see it's lagging behind a bit, which I think has to do with the fact that I'm recording this. So, because earlier it was running rather fluently. So let's try with a different millisecond count. Start this again. Let's see if this helps. It does. See, it's becoming more fluent, much less laggy. And if I go into the 3D view, there we go. Right, so I have actually noticed that there were some dropped frames in my recording. So this is using quite a bit of CPU time. So keep that in mind when you play around with it. In any case, this is a really cool thing to play with, and I have been using this as in a project where I used one of these Microsoft Kinects, and I collected all the Kinect data in another application, put it all into OSC packages, and I sent the Kinect data through OSC into Cinema 4D to map live onto a skeleton in here. And that worked very nice, really. And because it's going over the network, you can actually capture all your data on a different machine and have cinema run on a completely separate workstation somewhere else. And of course you can think of all other kind of stuff like audio hardware, for example, that oftentimes uses OSC as their default protocol, and you could think of doing some sort of live capturing where somebody plays with that hardware and you capture that data live in Cinema 4D and use it to create geometry. Okay, so I hope this was interesting to you, and two entirely different ways really to use external data. The file-based way, which is more like an offline way, where you can just read in XML or, for example, also JSON data. There's so many different formats out there, or you can read in custom formats, of course, as well. And that's the live way, where you can actually connect cinema over the network to another application and just capture data that way. Anyway, I think this is it, really, guys. This was Cinema c4d208, and this was the last class, and I really hope that I helped bring you guys Python a bit closer with Cinema 4D, and I'm looking forward to see some of your projects in the forums, and yeah, let me know what you did with whatever you learned in here. Hope to see you again soon, and bye.